So I decided I'd had enough PowerPoint and Keynote and everything else, so I wrote these slides in a text file, and we're going to be watching this with more. And also I don't want to go blind, so I'm sitting down, because otherwise the projector will be in my face. So I'm talking about continuous integration when infrastructure is the product, and I'll explain what that means, but roughly speaking, we're talking about testing infrastructure. So first I need to tell you a little bit about Acquia Cloud, just so you have some context. So Acquia Cloud is a platform as a service for PHP apps. Think of it as Heroku for PHP, or Engine Yard. It runs a LAMP stack, right? Linux, PHP, MySQL stuff. It provides multiple environments for our customers' applications, so dev stage and prod, and there's a lot of automation where we make continuous integration easy for our customers, and we give them a UI and an API and all kinds of good stuff. And Acquia happens to be focused on Drupal, so Acquia Cloud has a lot of special sauce in it for Drupal, though it works perfectly well for other PHP apps also. It's pretty big. We have about 3,000 instances running in EC2 currently. And we do a fairly decent job, not a perfect job, but a fairly decent job of continuous integration. So we make releases about every 1.5 days on average. And our releases, sometimes I get a little frustrated when I see, Flickr released, 47 times in a day. Maybe those are all really hard releases. I bet a lot of them are like just code changes, or maybe some of them are JavaScript. They're pretty lightweight, right? When we do a release, we're altering the infrastructure, running thousands of PHP web applications that we didn't write, that we don't control, we don't know anything about them. So, and our customers get really upset when their sites go down. So we have to be really sure when we do releases, or as sure as we can be, that we're not going to screw anything up underneath someone else's app. So just for a picture of what the whole environment looks like, I actually did this diagram a couple years ago. The details aren't that important. In purple off on the left, we have some central infrastructure servers, right? We use Puppet. We have a central controller database that knows about all our servers and customers and their domain names and SSH keys and their code repos and stuff. We monitor and we do backups and all that stuff. And then we have a whole bunch of servers that are kind of in a fairly standard web stack, right? Load balancers, web nodes, databases, file systems, right? The details of that are not important. And it's all in EC2 except for that little outbound email thing, which we're not going to talk about today. So, okay, that's roughly what Acquia Cloud looks like. So I'm a software engineer, and there's software development methodologies, right? There's waterfall, the way people used to do things, which completely sucked and never worked. And there's Agile, and we all talk about extreme programming and Scrum and Kanban. Acquia happens to be a Scrum shop, works pretty well, I think. Generally speaking, it's better, though I did appreciate, I think it was one of the keynotes yesterday, who they said, rapid deployment and Scrum and all that is terrific if you're shipping a web application, because frankly, it's a web app. If you're making a pacemaker or a space shuttle, different rules apply, but that's not what we're talking about today. So then there's this thing called continuous integration, which gets a lot of press. It's just about good software development practice and methodology. And there are these principles. These came off of Wikipedia, the 10 principles of continuous integration. Today, we are going to talk about just a few of them. And we're going to talk about just testing, because really that's sort of what I have time for. But the point is that we're talking about server configuration, the infrastructure part. Thanks to Puppet and tools like it, server configuration is software now. It didn't used to be. It's awesome that it is. And since it's software, you should treat it like software. You should treat it like app development. So we're going to talk today about making the build self-testing, testing in a clone of a production environment, and making that as fast as possible, and what that means for infrastructure. I love lots of people have said this, I say it too, if it isn't tested, it doesn't work. I just got a bug report this morning for one of our APIs. A customer tried it, it broke. I'm like, that's impossible. We have tests for that. Guess what? That particular function, it didn't have a test, and so it didn't work. And the other stuff, we do a lot of continuous integration stuff at Acquia, and maybe next time I'll talk about other stuff. So, by the way, feel free to interrupt with questions, though I may defer them to the end because I don't have a lot of time. So unit tests and system tests. Unit tests in software development are awesome, and everyone should write them, and test-driven development is terrific. But actually, it turns out to be not that useful for infrastructure. You can't mock out the operating system. You can't mock out the interactions between multiple servers and services and the web tier and the database tier and the file system and fail over. It's impossible. Unit tests don't do that. So we really work in terms of system tests. System tests are end-to-end. We test the system like the customers or like the end application will, which is great in that it gives you, confidence that it works from end to end. The problem is that it's really messy. So we run everything in the cloud, which means our system tests launch servers in EC2. Sometimes the servers don't launch. Sometimes our DNS provider is messed up. Sometimes, random things happen and our tests fail. And so we would love to say that every time we make a commit, we run our test and it's green board or we roll back. Actually, it's not like that. We have failing tests all the time. We go look at them and we evaluate, that was due to a cosmic ray. And we recognize many specific forms of cosmic ray. The Amazon EBS volume failed to attach within 3 minutes and we timed out. And then we relaunched the server and it worked, but meanwhile we logged a failure. And so we're like, okay, fine, and we go on. It sucks. It's been 3 years and we rarely get a green board. But without these tests, even in that state, we'd be completely dead. We would not be able to operate the environment. So, all right, I'm starting about server build strategy. So, as I said, we're doing everything in the cloud, and this talk ends up being cloud focused in addition to infrastructure focused. We always build from a reference base. So we happen to run Ubuntu. We always start from a plain, Ubuntu server image for a specific version, and we build from there. What we don't do is we do not incrementally evolve an image where today we install one package and then we make a snapshot, and then tomorrow we make some config change and make a snapshot again. If you do that, you don't know how to reproduce that. Fortunately, Puppet makes starting from scratch really natural, and so probably everyone in the room does this already, which is great. It didn't used to be the case. Unfortunately, building a server up from scratch can be slow. Sometimes when we're running our full install on an M1 small server, it can take 20 or 30 minutes just to build, install the packages and the cron jobs and all that, which sucks. And I'll talk to that if I have time at the end. So, all right, our system tests, we start with just basic build tests. We launch a bunch of machines, you saw that diagram. We launch a new controller and a backup server and then a whole web stack. And we start by just sort of making sure that they built right. We look for Puppet errors in syslog. We look for, Apache is supposed to be running. Is the cron job there? Cron tab -l pipe grep. We don't trust that just because the resource is in Puppet that it's there. We go check on the OS. Is it actually there? And so we look at config files and modes and things like that. Pretty standard. So our tests running on Jenkins somewhere are SSHing into all these servers and testing all these things. Those are the build tests. So, whoops, hit the wrong button. Then we start functionally testing what I call the moving parts of the infrastructure, right? So your infrastructure doesn't just run your app. It actually does other things on its own, like you make backups. So we trigger backups. In our case, we make EC2 snapshots. We actually make them. We verify that they're there. We restore them. We look at the data. We make sure the data contains what we think. We put, if we're making a database backup, we create a Sentinel database and a table, and we put one row in it, and then we make the snapshot and make sure that that's there when we restore it. If your infrastructure, some people use message queues and workers, and you should hammer your message queues and get your workers behind and verify that your auto scaling happens. We don't actually do a lot of message queues, but some people do. We use ELBs, Amazon Elastic Load Balancers. We have them pointed at multiple servers, so we create an ELB. We start hitting it. We take one of our load balancers down. We make sure that balancer came out of the ELB, but the traffic kept being served. Then we take the other one down and put the first one up, and so forth. We have database failover, so we shut down one of our databases and make sure we can read and write to the other one, and then we bring the first one up and make sure our failback works. All of these steps, we're SSHing in and doing stuff.
Sounds like that chaos monkey that I mentioned in keynote.
It kind of is like that. We've sort of scripted it. What I tend to say about the chaos monkey is I can't imagine why they wrote it. Amazon is our chaos monkey. So we have no source of machines crashing all the time. But the guys at Netflix are very good, and so I'm sure they had a good reason. We haven't found it necessary yet. Yeah, right. The last ones are really interesting. So like, we use, as I showed in the picture, we use Nagios for monitoring. We also have Nagios trigger auto recovery. So, if Apache is down, it sends an alert, but actually before it does that, it just goes and tries to restart it. So we log into a box and we shut down Apache, and then our tests wait, and like 60 seconds later, is it back yet? And then we go look for a log entry that says, it's back. Not only is it back because Nagios started it, not because like, sometimes you try to shut down Apache and it doesn't close because some random script kiddie in Eastern Europe has connected and your Apache won't shut down or whatever. So we check all the moving parts. And in a sense, this is kind of like a unit test. It's an infrastructure unit test. We're just doing it by hand, connecting straight to the database, connecting straight, twiddling the server up and down. Okay. So another little wrinkle is security compliance. Not everyone has these issues. But on Acquia Cloud, we host sites that are HIPAA compliant and FISMA, which is a government thing. And those impose requirements on us. So for example, so they impose requirements, and the important point is test in a clone of production, right? One of the principles of CI. Clone of production means if there's no backdoor in production, there's no backdoor in test. So for example, we can't log into our own servers directly as root with SSH. We SSH in as an administrative user, and then we sudo. And there's sudo rules in place. So our tests have to do the same thing. They can't log into root to shut down the database. They have to SSH in the way an ops person would. So we happen to use Wicked, which is a two-factor. It's like the RSA secure key thing. It's an open source version. So one of the things Wicked supports is you can use a device. You don't have to buy a little token. You can use your phone as a device. You can also use your computer as a device. And there's a command line version. So we wrote a script in the expect language. Does anyone remember expect? Everyone laughed at me. But so we have a little script in expect that can actually get a token and then SSH in and then run sudo. And our tests, every single thing they do is they SSH in as a test user and they run sudo bash the thing. And the day that we didn't start with this requirement. For the first 2 years, we didn't have it. And then when we added, we turned on the bits that said, okay, everyone has to come in via this other user and run sudo. And then we had to go change all of our tests to like work this way. That was a pain in the neck. Anyway, but it's important, because the thing is, if you don't do this, then you don't know that your tests aren't passing because they're doing something that won't actually work in production. Our servers talk to each other, sometimes over SSH. If we had a backdoor open so that the tests could get in as root, then how do we really know that our job server isn't talking to our web server as root? And then if it is, in production, it will fail. Hopefully, right? I mean, worse would be it succeeds because it actually can get in as root when it's not supposed to. But again, test in a clone of production. So then, that's all still just infrastructure tests, right? Now, we actually install the application or a sample application. As I said, we host customers using Drupal, so we install Drupal sites. And then we start exercising the Drupal sites. And we exercise them, not just like, does the app work? But we exercise them in ways specifically designed to make them hit each part of our infrastructure in the way they would naturally do in their own operation. So, we hit the Drupal site in a way that like writes data to the MySQL, and then we go log into the database server and say, is the content there? A lot of Drupal sites use Memcache. We support Memcache. So we do a thing in Drupal that triggers it to put an entry in Memcache and then go talk to the Memcache server. We don't just, talk directly to the Memcache server because, maybe the Memcache daemon's up, but the exact version of the PHP extension that the Drupal module is going to expect doesn't have the feature, so that in the end, it breaks. So we go straight in through the app and then verify on the back end that the thing happened that we thought would happen.
That's sort of an end-to-end example, right?
Yeah. I mean, so, it's different levels of end. This is really end-to-end because we're doing, what the app does. We also force the app to operate in a degraded environment to the extent that we support that degraded environment. So different levels of our product have different levels of HA. So, but some customers buy, automated database failover. So we install a Drupal site, and then we shut down its primary database, and we go hit the site, and we make sure that the application fails over to the passive database server and does the thing it's supposed to do. And then when we bring the master back up, that the Drupal site can actually see the content that was written to the other place and all the things that are supposed to happen. So, application testing. Okay, Reboot testing. So at the beginning, we launched our servers, we ran our build tests, we ran all this other stuff. And then at one point we realized, we're not even really sure that these machines will work if they reboot. And we rebooted them, and it turned out like Apache didn't come back up, because we'd forgotten to put the line in the Puppet service description that says, whatever it is, restart at reboot, enabled, I think, enabled true, and that puts the init script somewhere in place. It's a very easy thing to do, but if you don't reboot your servers, you're not sure. So, file systems mounted, services restarted, you need to check that. So we reboot the servers partway through the tests, and we do a sort of specific set of checks, and then we run the second half of our tests. What would be better is if we actually reran the whole suite of tests. After, launch the servers, run them, reboot them, run all the tests again, and then, go to the next page, do a relaunch. This is where, again, this is a cloud environment, where, sometimes the chaos monkey comes along and just takes your instance away. So what do? You rebuild a new one from scratch. We need to test that as well, because the instances are not all stateless. We happen to use EBS volumes under various conditions. So if we have a database server with an EBS volume, we need to know not only that we can relaunch the server, it will reattach the EBS volume and it will properly use the data. We've had bugs, for example, where our Puppet was missing certain dependencies, certain require statements. So like MySQL might start before the EBS volume gets mounted. And then, what is it going to do? Varlib MySQL is already a symlink off somewhere, but since that mount point isn't made yet, MySQL looks, sets up the local ephemeral disk, and then the volume gets mounted on top of it, and all kinds of mayhem results. So, we actually test this and have found real bugs that way. So starting each of the VMs over from scratch. And we found some really surprising ones. That one thing just happened. So we recently found that our relaunch test, there was one of our server types that we didn't relaunch. Was it relaunch? Yeah, it was. We were rebooting it, but we weren't relaunching it. And you remember at the beginning I said if it's not tested, it doesn't work? Not one of our customer servers, not a server that the customer might touch, but one of our Nagios, was it? Yes, it was one of our Nagios display heads that we run. So it's more of an infrastructure server. We were not relaunching it in our tests. And when we actually did, we discovered it didn't come back up. I actually have no idea why, but we discovered that we use a RAM disk, tempfs. And for some reason, we mount the thing, Puppet puts into fstab, and when the server relaunches, it just hangs. If we take that entry out of fstab, the server boots. I have no idea why. So at the moment, we can't relaunch that server, but we didn't even know we had the problem because we had forgotten to include that in our relaunch tests. If anyone knows why I can't relaunch a server with tempfs in fstab, please let me know. So anyway, and then ideally, you rerun all your tests again. Upgrade tests. Okay, so far we've been talking about launching new servers. We run this on the master branch every night or during the day as people are developing. That's great because we're testing brand newly launched servers. And frequently you have to launch brand new servers, right? Your service grows, you need more things. You scale horizontally or you have new customers or whatever. Terrific. But also, we have 3,000 servers running. And when we do a new release, we don't shut all those servers down and relaunch them. We install the new version on top of the old version, right? And Puppet installs new packages and does its thing, and our other software does its thing. But that's a different flow than launching a new server. So there's the upgrade test dance, right? We don't first want to practice this process on our production servers. So we launch servers running our old stuff, install the app, make sure it works, then upgrade the servers to the new stuff, and then make sure it works. This is something we've only just started actually doing fairly recently. Before this, we did it relatively manually, and it was painful, and it slowed our release process down. So, as I said, we just started doing this. So an issue with the release process is, okay, so you can have Puppet or other scripts that you write automate almost all of your upgrade, right? Normally, you run Puppet, the whole point is it's idempotent, so it just makes things look right. And it does, and it works great. But there are some things that Puppet can't do. So if there's something, well, so for example, I have a few examples. Rolling upgrades across HA clusters, right? Sometimes we need to, upgrade the active database master and the passive database master separately so that the customer site stays up. If we upgraded them at the same time, then maybe both MySQL daemons would restart and then the site's down while they're both down. So we have to do the left half, and then we have to do the right half. But that's not something Puppet can do across servers, so you need some kind of external dependency graph to say which things to do first. Sometimes we have to update the web nodes before the database servers, or before the job servers, or after the job servers, or like it can go in a variety of orders. Sometimes there are post-release tasks, which is like, okay, after this release, we no longer need that hacky script that we wrote 3 years ago, so let's uninstall it, but don't uninstall it until everyone's on the new release. So these are all just things that are, right now we put them in a text file as part of the release, and ops reads it. And they're like, oh, these are the things we need to do. But what that means is that if we have an upgrade that involves that, we cannot automate its test. And so we're working on that. We haven't yet fully built the ability to specify, all the different points in the dependency graph where we should do this after those things happen, and then et cetera. And so we're still trying to figure out how to make that work. How am I doing? I'm actually going a lot faster than I thought. Okay.
Quick question on the upgrades.
Yeah?
Do you also do the same cold restart tests? In other words, after the upgrades are done, then restart the entire, the testing?
I don't. So we're still working through automating the upgrade tests, which is why I didn't occur to know. I don't think we've thought about that, like doing the upgrade and then rebooting. It's a good point. Probably should. All the things that I have here, it's like, oh my God, you really need to do that one too. We've found bugs for all of these. We found reboot bugs, we found relaunch bugs that didn't show up in the normal just start the server and run the test. They all happened. So, okay. Okay, server builds. At the beginning I mentioned, server builds can take a really long time. We're actually using a fairly old version of Puppet. Maybe newer versions are a lot faster. Though, Puppet can only be as fast as sucking the packages down from the mirror, from your apt mirror or whatever. There's a certain amount of inherent work Puppet has to do. So you have to start by always building from a reference base, no incremental machine images. But it's very slow. So what we've just actually started doing is we're automating builds of server type images every night. So we're always building from scratch, but then each night we snapshot those so that for the next 24 hours, we can launch tests using those pre-built images. This makes the tests during the day take a lot faster, run a lot faster. So if I want to do a test run, instead of waiting 30 minutes for my suite of 20 servers to start, I can wait 3 minutes for my suite of 20 servers to start. Makes the developers a lot more productive. The next thing we will be doing, haven't gotten there yet, is doing this in production, so then it's going to reduce our mean time to recovery. So if one of our servers fails and we can relaunch it in 3 minutes instead of 30 minutes, that's a lot better. For our HA product, it's not so critical because we have HA and other servers are taking over the load, but even so, that means it's better if it's faster. Even doing this, we found in principle this shouldn't be too hard, right? You run Puppet and you make a snapshot. Turns out it isn't that simple. So one random example. So you run Puppet, you install, excuse me, pardon me. You run Puppet, you install MySQLD. What does it do? It initializes varlib MySQL and it puts some initial binary files and all that there. Well, we don't put that on the ephemeral disk, which is when you make a snapshot in EC2, what's stored is the root partition. We don't put that there, we put that on EBS. Well, so if we're launching a server and an EBS volume that are going to be a real server in production, then that server and volume are paired forever. And so when we relaunch that server later, we're going to put that EBS volume back in place and MySQL will use it and it's all good, assuming we got the mount order and all that right. When we're bundling these servers, you install MySQLD, it's going to initialize a data directory, but it's not initializing it on an EBS volume that it's going to have later. Because, I guess we could snapshot the EBS volume and always use that snapshot to go with the server that it was bundled with. And now that I mention that, that might actually be a really good idea. But since we aren't doing that yet, what we do is we discovered we have to launch the server, attach the EBS volume, install MySQL, and then take the data directory and move it over onto the root partition into, var lib MySQL pre-built or something. so that when we instantiate that server later and run Puppet, Puppet will say, oh, MySQL is already installed, but before I can start the service, I need to take this directory and move it back to the EBS volume. Because otherwise, MySQL is going to get all confused. Now, what that means is that normally when we build our servers, because of our reboot test, we make sure that MySQL is in the init script so that it starts on boot. But when we're going to snapshot the machine to bundle it, because we had to take the data directory, move it out of the way, and we have to put it back before MySQL can start, we have to make sure that MySQL isn't in the init scripts to launch on boot, because otherwise it'll start on boot and its data directory won't be there. And a few minutes later, Puppet will come along and put it into place, but by then mayhem has already happened. So, none of these things are hard, but as you just have to sort of work through, oh yeah, another little wrinkle that we have to work our way through. So, as I said, we're working on that now. And then once we have those, right, now we need to test these things. So we're going to create them nightly. We're also planning to, once we go into production, we'll make, we work on, release branches and tags. That's how we do our deployment. And so when we cut a new release, version 60, we'll make bundles for version 60. And then if we do hot fixes, 60.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll probably just use the same base images and allow Puppet to do the final push to the hotfix, because the hotfixes are relatively small. So what this means is, when we run our tests, we need to test not only starting from the base image, because we may still launch from a base image at some point. Maybe eventually we'll realize we never launch from base images anymore, we can stop, but for now probably we're going to keep doing it. But then we also need to run our tests with servers launched from the pre-built images. And of course we need to test our upgrades from the per branch release, the 1.60 that we created last week and pushed out and we have running in production. We're going to have to launch our servers running that bundle and then upgrade them to last night's built master branch bundle. Yeah, remember when I said this was the hardest thing I'd ever done? All right, moving right along. Okay, and then this is almost sort of boring and easy by comparison. Cleaning up, you launch all these servers during your tests, and we write our code to have exception catching, and so when asserts happen, we go and do our cleanup at the end. But it doesn't always work. Sometimes you call destroy instance and it doesn't die or something. So you need some kind of database of all these servers that you're launching, which probably if you're launching and killing them, you already have. Turns out EC2 tags might be enough, because you can just tag the image as this was a test image, and then it's easy to go back later and clean it up with an audit process, which you need, because if you don't have one, you will leak a bunch of servers. We've done it. Your bill gets run up. It's very expensive. We found it very useful to have separate AWS accounts for this whole shenanigan, so that if we ever need to, we can just say, take the test account, and kill everything, because it's all tests. And worst case, some Jenkins job will fail, but we don't really care. And that works pretty well. I went through that a lot faster than I thought. So we've got about 10 minutes. What can I tell you?
What are you guys using for automatic spinning up? Is it like CloudFormation or CloudFormation or in-house stuff?
In-house stuff. So we started this product in March of 2009. So a lot of the things that exist now didn't exist then. There was no FogGem or libvirt or all that. So we wrote a lot of stuff ourselves. And if we started now, we would use a lot of things that people are talking about here. But to convert from what we have that works, thank you, to convert from what we have that works to new stuff is just extra work. Which is annoying. Someone in some talk earlier today said, oh, it was the keynote. It was the guy from CERN. Great talk, by the way. Who said, people come work with us for 5 years, and when they leave, they have really valuable, marketable skills. To the extent that we built stuff before the current generation of tools, and people are learning that, I was sitting there thinking, I wonder how frustrated my team is that they're not working on the latest cool stuff. And that might be a reason to convert, even though from an engineering perspective, we don't really have to. So we might think about that.
Is any of the work you've done available on GitHub or anywhere else?
Most of it is no. So in terms of our tests are an enormous pile of custom code. So one of the guys in the audience, Rudy, used to work for us, and as he can tell you, it's hard and it's ugly because we didn't know what the hell we were doing when we started, and we just sort of glommed stuff on, and our server launching infrastructure is all completely custom. So this talk is really just more, here's the things you should think about. How, you don't necessarily have to go as far as we've gone, because maybe, you're not running as many servers for as many different kinds of apps as we are. But, these are the check boxes that you should decide, yeah, do that one, don't do that one, etc. Random quote, random plug, we're hiring. I don't know how many of you would like to live in Australia, how many of you have partners who would like to live in Australia. But we actually are looking for people in lots of places. So anyway, there were some other hands.
Have you tried using this for testing Puppet upgrades?
You mean testing versions of Puppet, or?
Upgrading from one version of Puppet to the next. Using that for finding out if it still works the way you expect.
We have not upgraded from one version of Puppet to the next in a very long time. No, we actually just recently looked very seriously at it because we can't use RubyForge. We're too old for that. I think we're on 0.25. And so we looked at 2.6 and we discovered that there was bug X that said all versions prior to 2.6 were unusable for us, and there was bug Y that said all versions newer than this other version were unusable, and those two versions, there was a disjoint set of nothing worked. So we'd have to go to 2.7, and the rewrites were a little more than we wanted to take on at that moment in time, and maybe we'll go to 3.0. I give that answer a lot, and it's just that it's working, and we have so much to do that to re-engineer things that are working. Puppet 0.25, frankly, it works really well for us. I was talking to one of the Puppet Labs guys, and they're like, "What are your pain points?" And I'm like, "My pain points are not with Puppet. Puppet's great." So, yeah.
I think that you mostly answered it with the first question, but what types of tools have you used to write those tests in? I've started doing something very similar to this with my infrastructure.
Mm-hmm.
I've used Cucumber, so that basically my test definitions for that is documentation for testing the infrastructure. I just wondered what you're using.
We wrote it in Ruby. What is it called? The standard Ruby unit testing framework, actually, which test unit. Thank you. Which, of course, I started with the point that these aren't unit tests. Okay. So an issue with that is that our tests produce miles and miles of output, and then when there's a failure, it sticks the stack trace of the failure at the bottom. And then we're like, okay, now we got to go find where in the logs that actual error occurred. So test unit is actually the wrong tool for this, but it's what we're using. So, okay, well, I am out of time. Thank you.